Hey guys, for this lesson we're going to be looking at the very beginning of particle kinematics in one dimension. So first we'll look at some prerequisite definitions before moving on to understanding the ways in which we actually quantify movement. So movement in math terms that we can understand and manipulate. So let's get straight into the definitions. The two definitions we're actually going to look at are scalar and vector quantities. Now, a scalar has only a magnitude or a strength. Such as speed. For instance, if you're looking down at your speedometer in your car, it'll just say 60 kilometers an hour, 40 kilometers an hour. It won't tell you which direction you're actually going. A vector, on the other hand, has magnitude and direction. For instance, temperature is a vector because you could get a reading of 2 degrees, and that can be both above or below 0. So that above or below is actually direction. Positive or negative is actually the direction in temperature. So let's move on to quantifying movement. There's going to be a few more definitions as we go. First, we're going to look at distance versus displacement. Now, distance is pretty self-explanatory, but displacement, on the other hand, is not. So let's look at the definition. The final distance and direction of a body from its starting point. So that distance and direction, magnitude and direction, make it a vector. Right, the best way of understanding this is actually through an example. So let's have a look at an example now. I've drawn one up over here, so we can see my little body over there, that little red dot, and we got our example. So let's say this first moves 2 centimeters to the right, and it then moves 3 centimeters to the left, right. What we're going to do, why there's this little plus here, is we're actually going to define the right as the positive direction. Now that'll make sense in just a moment. So the distance is quite obvious. It's moved 2 centimeters and 3 centimeters. It's moved a total of 5 centimeters. Its displacement, its final position, is in fact just 1 centimeter from its starting point. The way we write this is we say 1 centimeter to the left, or as we defined to the right as positive, we actually write this as minus 1 centimeter. So that's displacement and distance. Another way of quantifying movement is we look at a body's velocity and speed. Now speed, we spoke about before, velocity is actually the rate of change in displacement. So because displacement is a vector, so too is velocity, whereas speed is just a scalar. Right? I've written a little formula here. Velocity is actually equal to the change in displacement over the change in time. So that little triangle actually means change in. Right, so it's the way your displacement changes over time. The rate of change in displacement. So I've got another example to explain this. Here's actually the same example as before, only this time it took place over 4 seconds. So what we're going to write here, the speed, it went 5 centimeters over 4 seconds, right? So that's actually 1.25 centimeters per second. That's how we write that. It goes 1.25 centimeters every second. So its distance changes by 1.25 centimeters every second. Its velocity, on the other hand, again, it only ends up 1 centimeter to the left, or minus 1 centimeter. So here, it's actually ended up 1 centimeter, and that's taken it 4 seconds. So that's actually minus 0.25 centimeters per second. So that's its velocity, its average velocity. And so now we've got distance, displacement, velocity, and speed. The last method of quantifying movement that we're actually going to look at is called acceleration, right? Now, acceleration is the rate of change in velocity. So our velocity was the rate of change in displacement. Acceleration is the rate of change in velocity. How fast is it speeding up or slowing down, right? And we've got a little formula here. Acceleration is the change in velocity over the change in time. So it's very similar to the velocity formula, just a few letters changed. Here again, we've got an example. Example, in 12 seconds, a body accelerates from rest to 24 meters per second. Find its average acceleration, right? So we know that A, it accelerated from rest, so its change in velocity is actually 24 meters per second, because from rest means 0 meters per second. So its change in velocity is 24 meters per second, and that took 12 seconds, right? So we end up with its acceleration being 2 meters per second every second. So its velocity increases by 2 meters per second every second. Or another way, more compact way, and a more acceptable way of writing this is actually like that, 2 meters per second squared. So we've got displacement, distance, velocity, speed, and acceleration, all our methods of quantifying movement, and that actually concludes this lesson. Thanks, guys.